Okay, here we go, folks. This is session 2 of robotics. Now, I have changed my mind. I'm only going to do 2 videos for this because you've had the first challenge, which is looking at using the touch sensors. Now, that one might take you a little bit of time, but that's okay. This session 2 is going to be after you've built your first robots, and the instructions for that are pretty simple. So follow the instructions for the guide, use the classroom teacher's instructions to know which group you're going to be in and which robot you're going to be using, and then work together and get the build done as quickly as possible. It may take you a full session, but it should only take you one. Okay? What you're going to be doing now is you're going to be completing the maze challenge. Now, this is where we're going to separate things out between Robotics 1 and Robotics 2. Robotics 1 is going to be allowed to do movements based on time. Now, what that means is that you're going to have to turn your motors for a certain amount of time to turn 90 degrees. How long that is, that's up to you to test out. I'll show you how to do it in programming. It'll be up to you to program it and then test on the different surfaces to see what happens. Robotics group number 2, you folks have to use a gyro sensor. There it is. Robotics 2 people must complete the maze only turning using sensors. So you will stop turning when the gyro sensor tells you to do it. You will start turning when the gyro sensor tells you to do it and when the ultrasonic sensors tell you when to do it. So this is the point where you go, what maze challenge, what are you talking about? Well, this is the point where I cue the video on the robot completing the maze challenge. Alright, so here we go. I've got my robot connected and I can see over here that all I have to do is just press the download button. I hear that little thing and the robot's ready to go. So we'll disconnect, bring it on over to the maze. Here it is. I'm going to position my robot here. Now on the screen, go over 1. There's my group project. Click on that. There's Maze Runner, and let's run the program. And this is what your robot needs to do. Now at that point, if your turn hasn't been too precise, I will let you nudge it a little bit. So once again, not too precise, a little bit of a nudge. It's made it through, and without turning it off, run it through again. And that's it. So it has to go through the maze autonomously, no remote control, using the ultrasonic sensors, but it has to go in both directions using the same program. So you just saw the robot, the Mark II, going through the maze, and it went through twice. All right, it was able to use its program to get through the maze in one direction and then get through the maze in this basically in reverse, which meant that it was not 2 programs, it was just the one program. Now, how to do this? This is all about decision making. This is about planning out what the robot needs to think whenever its sensors give it information. So this is, and I'll show you how to do a basic version of it on the screen here, but this is where your program comes in, and this is where your planning comes in. So let's have a look at the robot itself. The robot itself has got, and in fact, we should draw it up here. This will probably be a bit of a rough cut, but hey, what are you going to do? So let's actually do up a little sketch of the robot, which you can do as well. So, and you probably should do it for your work. So here's the robot right here. All right, good old robot. And what we know about Mr. Robot is that he has got, or it has got, gendered pronouns aren't really needed with robots. It has got two motors, one here, and we'll just copy that across and not make it ugly, and one here. Oh, look at me pressing Control V the wrong way. Okay, so this here is motor A. This here is motor B. Now these motors are going to need to turn in a particular way in order to get the robot to work. So if motor A is turning, which is on the left, and motor B is not, you should get yourself a turn to the right. Motor B is turning, and motor A is not, that should get you a turn to the left. Okay? But as you noticed in the maze, your robot's going to need to pivot on its center, which means A needs to be going forward, and B needs to be going backwards. Or the opposite way around, depending upon which way you want to turn. A forward, B backwards means you should get a spin to the right. B forward, A backwards means a spin to the left. Okay? But here's the thing. Program it, test it, see what your robot does, play around with it, and learn about these things about your robot, because it's going to be slightly different from everyone else's robot. Not all motors are exactly the same. So, test. Okay? But what else do we have on our robot to help us out here? We've got sensors. So let's put on a couple of sensors here. And we've got an ultrasonic sensor in the front, right here. Let's make you a different color, why don't we? Let's make you red. So we've got ultrasonic sensor there in front, and then we also have another one that is pointing to the left. So I'm going to call this left sensor, and I'm going to call this front sensor. And we'll make it a bit longer so we can see the text. There we go. So we have to ask ourselves a question here. As we're approaching the maze, what do our sensors see? So let's think about what actions that we're going to be taking and how we can put this down into a chart. So can I actually do a chart on this? Well, let's find out. If nothing else, we can just do text. So let's ask ourselves a question. Oh wow, look at that expand crazily over there. Let's move you back here. Let's ask ourselves a question here. If my front sensor sees nothing, what do I want to do? Well, if my front sensor is seeing nothing, then that means that there must be nothing in front of it, so therefore I can move forward. So that's our first action. If front equals nothing, move forward. But let's ask another question. If my front sensor is seeing nothing and my left sensor is seeing something, then what does that mean? Well, I've got a left wall on my side, but nothing's in front of me, so I can still move forward. But we still need to ask the second sensor what's going on. So we can say front nothing, left something is still going to be moved forward. Okay? I'm going to put a better state chart up on the website for you guys to look at, because this one's a bit dodgy. But yeah, anyway, moving on. So we come to our first wall. So front is going to equal to something. Now, depending upon what the left sensor sees will determine the direction that we turn. Because when you think about it, if the left sensor sees something, that means there's a wall there. If the front sensor sees something, there's a wall there. What direction is there left for me to go? Let's go the other way. Or if I see something in front of me, but nothing on my left, then maybe I can turn left. Don't know. What you're going to have to do is get your robot into the maze and actually have a look. Plan it out. Create a chart, and then you can turn that into code. So that's just a basic example of how you can plan it. I'm going to ask you guys to do something a little bit more detailed and probably neater, because yeah, that's a bit ugly. But let's look at our program. Okay, first of all, let's call the program what it is. So we press the plus button up here to get a new program. There's my touch remote one, which I'm not going to show you because I don't want to give away the secret just yet. But, because the solution's in there, but let's call the program what this one is, which is Maze Runner, because why not? Young adult fiction. Woo! So we're going to create our little Maze Runner here. First thing we're going to want to do is we want the program to run all the time. So we go to our control flows and we get ourselves a loop. And we're going to put that loop in there. Now, we're going to have to ask ourselves a question first. We always want our program to start with a decision. So what is that decision going to be? And in this case, because it's a decision, it's a switch, but our switch is going to be based upon a different sensor. In this case, it's going to be based upon our ultrasonic sensor. And we're going to compare the distance centimeters. Now, this is a part where you want to get your port view and be able to look at what you can actually see. So get your port view system, or take your robot over, look at the port view, put it in the places where the robot's going to have to make a choice, and see what your sensor sees. Judge for yourself how far it's going to need to go. Okay? So, but I'm going to make sure that it's the ultrasonic sensor on the right port. So my front sensor I'm going to ask the question of first. Do I see something? And we'll get to the comparison, which in this case is going to be less than, and let's say maybe 20 centimeters. I haven't done my port view yet, so I'm just guessing there. So if I was doing this the right way, I'd take my sensor over and do it, but you could do that. I'm just going to program. So we're asking the question, do I see something in front of me? Now, if I don't, well, guess what I'm going to do? Keep going straight forward, because that is my overriding function. If I see something in front of me, or if I don't see something in front of me, I'm just going to keep going forward because that's what I have to do. So we're going to press the move tank, and once again, we're just going to turn it on. We don't want it to be on for rotations, degrees, or seconds. We just want the motor to be on, okay? Have a think about what you think would happen if you set it on for seconds or degrees, and write that down in your blog. I want you to, in your reflection journal, I want you to actually think about the question, what would happen if I had my motors going on for a time limit as opposed to just on and using the sensors to say yes or no? Have a think about what might happen. Now, we're going to make sure it's the right motors, A and B, but if your robot is plugged in at this point when you're programming, it should detect what sensors they are and do them automatically, but always double check. That is the big thing that always happens with people's programs that don't work. Motors not set properly, sensors not set properly. Check those things. I'm going to change my speed down to 20 because I don't want to be too much of a speed demon. We just want to move. But there we go. That's a decision. If my sensor sees nothing in front of me, so if that, once again, that's if I see something less than 20, which means I do see something, I'm going to have an action here. But if I don't, I'm going forward. Now, let's go back to this one. I see a wall in front of me. What is the next thing that I want to ask myself? Now, we did this in our state chart to a degree. We know there's something in front of us, but now we have to check to see if there's something next to us. So what we do there is, we go back to our control flows, and we're going to drag up another switch right here, okay? That switch, we're going to compare to our ultrasonic sensor, and we're comparing distance centimeters. And at this point, we're making sure it's our left sensor, which for me is on port 3. And once again, asking, do I see something less than, and let's go for our average 20 away. This is where we can expand our program out a little bit and maybe give ourselves some more space to operate because it is getting a bit big. So, now we've got our other switch in there. So, we follow the loop through. Loop starts. Do I see something in front of me? Yes. Do I see something beside me? Yes. So that means here, I should be turning, if something's on my left and something's in front of me, I should turn right. Okay? Here, which means something's in front of me, but nothing's to my left, meaning that I should turn left. Okay? So, let me put in my move tank over here. Now, we set the motors correctly. Now, this is the part that separates the beginners from the continuing robotics students. Beginners, you are going to be able to go on for seconds, degrees, or rotations. Now, just a little thing here. There is a reason why these little tags are on the wheels here, okay? Because on for seconds means the robot will turn the wheel for a set number of seconds, okay? Rotations means one of these is one rotation. The wheel went around once, so if you ask it to go around twice, then it'll basically go like that, turning the wheel around. Degrees is degrees of the motor. So this is a 90-degree turn. That ain't much. This is a 100-degree turn, a 180-degree turn. I do maths, yay. All right, 270, 360. All right, so be very careful which one you're using. And as always, if you want to know how to exactly execute a 90-degree turn, do it on your robot. Move the wheels to make it happen and observe, see what they do, and use that to determine your program. Because you could observe it and go, well, hang on, if I have my front wheel going at speed 20, so, and my other wheel going at, now here's the thing, negative 20 means that I'm putting it in reverse, okay? Positive numbers, wheel goes forward, negative numbers, wheel goes in reverse. So that's 20 and negative 20. I know if I do that for 2 rotations, I get a 90-degree turn. Yay! Okay? That may or may not work for you. You've got to use your robot to decide. Robotics 2 people, you have to use a gyro sensor to determine the movement for your robot. Okay? So, that's the program. And I kind of have spelled it out for you there a little bit, but you have to fill in the blanks. I've only given you the first little part of it, but hopefully you should be able to use that to figure out the rest. What you now need to do is make sure you've built your robot, written your program, you've tested it, okay? And when the program's successful, you need to make sure you've put this entire process into your journal, okay? Especially if the robot doesn't work, especially if you get a turn incorrect. Put everything into your journal. Put your state chart into your journal as well. So when my sensor sees this and this sensor sees this, what action do I take? That list, put it in your journal. What does a 90-degree turn look like on my robot? Put that into your journal, all the different settings. Get them in there because that information is going to be really useful for you in the future. Okay, once you've completed the maze and once you've completed the journal, you'll be able to move on to the research assignment, which is on the video of humans need not apply. Okay, go through that in the next session, and then by the time you finish that, I'll be back with some awesome news about robots from Japan. So, good luck.